Hi everyone, welcome back to my AP Calculus class. Today I want to explain integration by partial fractions. Okay, to the partial fractions, basically you have to understand how to find the integral of 3 over 2x minus 5 dx. This kind of functions integral. How can you find that? You understand integral 1 over x dx is equal to ln absolute value of x plus c. Basically, you can use this formula. Okay, but in this case, the denominator is not just x, but 2x minus 5 linear function form. So actually, you can use u substitution for this, right? So that 2x minus 5 equals u. That means 2dx equals du. Okay, so dx equals always what? 1 over u part prime du, because u part derivative is part just constant like 2 in this case. You can use u substitution anytime if the u part is mx plus b form. Okay, if we use u substitution for this problem, that is equal to integral 3 over u, and then what is dx equals 1 over u prime du. So 3 over 2 is coefficient, and then integral 1 over u du. So 3 over 2 ln absolute value of u plus c. What was u? u was 2x minus 5. So this is the final answer, right? But if integral 5 over x minus 3 dx, something like this, you can make that denominator part is u part as well. But in this case, dx is equal to du, because derivative of u part is just 1. So 1 dx equals 1 du. Okay, in this case, directly you can use, take out 5, you don't have to use u substitution, directly find that ln absolute value of x minus 3 plus c. Because dx equals to du, you don't have to use u substitution, right? So usually for the partial fraction integration, we use this kind of formula. Integral 5 over x minus 3 dx equals just use formula 5 ln absolute value of x minus 3 plus c. I'll give you some examples about integration by partial fraction from now. Okay, let's start. Example 1. Start from easy problem. What about 3 over x squared minus x minus 2 dx? It's impossible to use u substitution if u part the denominator part. 2x minus 1 dx equals du. U substitution doesn't work. Why? Suppose x squared minus x minus 2, that part is u. What is the derivative? 2x minus 1, right? Dx equals du. And then change this function to u function, 3 over u, and then change dx to du, 1 over 2x minus 1 times du. Usually in u substitution problem, this part should be crossed out, but in this case it cannot be crossed out, right? That's why it is not u substitution problem. We have to use partial fraction. I show you how to do. Integral 3 over. At first, factor denominator. Factor denominator. It is factorable. What are factors? X minus 2, x plus 1. Okay, and then change this fraction form to partial fraction, which means that should be equal to a over x minus 2 plus b over. Okay, just separate this fraction into two different fractions like this. And then I don't know what is a and b, so you have to decide. You have to find a and b first. So change this partial fraction form, okay, to just a common denominator. So what's a common denominator? X minus 2 times x plus 1. And then numerator is what? A times x plus 1 plus b times x minus 2. Let's simplify this. X minus 2, x plus never changed it, but what about numerator part? Ax and bx. So a plus bx plus a minus 2b, a minus 2b. This function fraction form should be equal to original one, which means a plus b part should be 0 because it's 0x plus 3, right? So a plus b 0, and then a minus 2b is 3. So if you solve this system of equation, a is 1, b is negative 1. You can use substitution, elimination, whatever you want, doesn't matter. Just find that a and b using system of equation. So a equals 1, b is negative 1. Okay, we found the 1 and negative 1. Just put these two numbers for a and b. A is 1, b is negative 1. And then we have to find the integral of this function. Okay, so what is the first part? 1 over x minus 2. Integral 1 over x minus 2 dx. It is ln absolute value x minus 2. And then minus 1. So negative ln absolute value of x plus 1 plus c. So this is the final answer. Okay, I give you one more example. Example 2. Find the integral x plus 2 x squared minus 2x minus 8 dx. It is not u substitution problem because denominator part is u part, derivative of u part 2x minus 2. 2x minus 2 is not cancelled out with x plus 2. That's why u substitution is not available. So just make two partial fractions. So first, factor denominator is x and x minus 4 plus 2 dx. It can be cancelled out. I'll change that to 3. It's better. 3. It's not cancelled out. Okay, now make these parts two fraction forms. A over x minus 4 plus b over x plus 2 form. And then find the a and b, how to make a common denominator. So x minus 4 times x plus 2, numerator be a times x plus 2 plus b times x minus 4. Simplify numerator, ax plus bx, a plus bx. And then 2a minus 4b plus 2a minus 4b. Denominator still there, nothing changed in denominator. And then this fraction form post be equal to original one. That means what? A plus b should be 1 because it is 1x. And then 2a minus 4b should be equal to 3 because x plus 3 over there. I want to use elimination. I want to multiply it by 2 at first equation. It's going to be 2a plus 2b equals 2. And then subtract. Then it cross out. Negative 6b equals 1. So b equals negative 1 over 6. That means a equals 7 over 6 because a plus b should be 1. So we just found that a and b. Plug in these numbers into this a and b. So a was 7 over 6. 7 over 6 times 1 over x minus 4. And then b is negative 1 over 6. So negative 1 over 6 times 1 over x plus 2. Find the integral of this function dx. So step number 6, just coefficient. And ln absolute value, x minus 4, minus 1 over 6, coefficient, ln absolute value, x plus 2, n plus c. This is the final answer. Okay, you need more practice how to use partial fraction to find some integral. I gave you only 2 examples, but if you want more exercise, you can use any textbook. But this is a BC only, so AP student don't have to know this. But for BC students, absolutely you have to know this. Alright, I explained the integration by part today. Please click subscribe and like and turn on the notification. We'll post 1 or 2 videos every single week. Thank you so much again for watching my video. Bye bye.